Hello students. Now our next topic is how to Thevenise a circuit. In our last lecture we have seen the Thevenin's theorem. Okay. Now if you are given some circuit, some network, and you have to Thevenise that circuit or that network, then how to Thevenise that circuit? For this, for example, we have taken a circuit here. In this circuit we have voltage source E equal to 12 volt, and also that voltage source has internal resistance 1 ohm. That is, the voltage source has internal resistance, its internal resistance 1 ohm. R1 which is of value 5 ohm, R2 which is of value 6 ohm, and the load resistance RL of value 4 ohm. Terminal A and B, terminal C and D. Okay. Now we have to just Thevenise this circuit. There are some procedures, there are some steps to Thevenise the circuit. The procedure for or steps for Thevenise the circuits. The first step is disconnect the load resistance RL. Disconnect the load resistance RL from terminal A and B. From terminals A and B. Step 2, with load terminals A and B open, calculate the open circuit voltage, that is VOC, or it is also called as VTH, that is Thevenin's voltage. Open circuit voltage, Thevenin's voltage. Okay. Now step 3. The step 3 is remove the battery and replace it by its internal resistance, and calculate R equivalent or RTH, that is Thevenin's resistance. And step 4 is replace the entire circuit by single voltage source VTH in series with single resistance RTH. And step 5 is connect RL between load terminals A and B. Now these are the 5 steps you have to adopt in order to Thevenise any linear circuit, any linear given circuit. Now in this circuit we have some values. Now by adopting these all steps we have to Thevenise this circuit. For this, now our first step is disconnect the load resistance RL from terminal A and B. We have to disconnect the load resistance. Now adopting step first, Step 1. Remove the disconnect the RL from terminals A and B. Okay. Now we draw the circuit by disconnecting load resistance like this. This is A, this is B, this is C, this is D. This is R1 equal to 5 ohm, R2 equal to 6 ohm, and this is E equal to 12 volt having internal resistance 1 ohm. Okay, now we have removed the load resistance from load terminals A and B. Now our second step is, with load terminals A and B open, calculate the open circuit voltage. Calculate the open circuit voltage, that is VTH or VOC, open circuit voltage. Now we have to just find out the open circuit voltage between these two terminals. Now we know that the voltage across the open circuit voltage A and B is equal to the voltage across the R2. Therefore we have to just calculate the voltage across R2, that is which is equal to the voltage across open terminals A and B. Now for this we have to find out the current passing through. फॉर व्होल्टेज अक्रॉस R2 आपल्याला माहिती आहे ओम्स लॉनुसार जर आपल्याला व्होल्टेज माहीत करायचं तर V इक्वल टू IR म्हणजे आपल्याला करंट माहीत पाहिजे, R आपल्याला आहे म्हणजे करंट माहीत पाहिजे. नाउ लेट अस कन्सिडर फॉर दिस वी हॅव टू फाइंड आउट द करंट फ्लोइंग थ्रू दिस रेजिस्टन्स R2. नाउ सर द करंट पासिंग थ्रू दिस लोड resistance R2 can be calculated as, suppose the current passing through R2 is, suppose I is the current passing through the resistance R2. Now we know that because of this voltage source, the current will flow through R1, current will flow through R2, current will flow like this. Therefore the current will flow from R1 equal to the current will flow from R2. जो करंट R1 मधून फ्लो होता है तोच करंट R2 मधून फ्लो होता है, आणि या R2 मधून जो करंट फ्लो होता है तो करंट फाइंड आउट करण्याकरता लेट अस फाइंड आउट द टोटल इक्विवेलेंट सर्किट ऑफ दिस सर्किट, टोटल इक्विवेलेंट रेजिस्टेंस ऑफ दिस सर्किट. नाउ इन दिस सर्किट R1 and R2 are in series with each other. Also the battery has its internal resistance. All three resistances are in series. Therefore the equivalent resistance will be just addition of all these resistances, that is 1 ohm plus 5 ohm plus 6 ohm. That is 1 plus 5, that is 6 plus 6, that is equal to 12. That is 12 ohm is the total resistance, equivalent resistance, and voltage is 12 volt. Therefore the current flowing through the circuit will be equal to voltage, that is equal to 12 किंवा आपण लिहू E upon 1 plus 5 plus 6, 1 plus 5 plus 6, that is equal to E equal to here 12 volt upon 1 plus 5 plus 6, that is 12, equal to 1 ampere. That is the current flowing through resistance R2 will be equal to 1 ampere. Now voltage, we have to just find out the voltage across A and B. Now we can find out the voltage across R2. That voltage across R2 will be equal to voltage across A and B, that is the open circuit voltage. Therefore the voltage across R2 is, that is voltage across R2 is, that is voltage across R2 म्हणजे voltage across CD, that is equal to voltage equal to V equal to IR. Therefore now we know that here the current flowing through resistance R2, that is equal to 1 ohm, and the resistance, that is equal to 1 IR2, that is equal to 1 into 6, that is equal to 6 volt, that is equal to 6 volt. And we know that the voltage across CD equal to voltage across AB, and that voltage is equal to the open circuit voltage, and the open circuit voltage called as the VTH, that is the Thevenins voltage. Therefore that is VCD must be equal to VAB and must be equal to VOC, open circuit voltage, and this is equal to VTH equal to 6 volt. Now we have found out the Thevenins voltage. Now our third step, we have calculated the VOC, that is VTH. Now our third step is remove the battery and replace it by its internal resistance and calculate the RTH. या सर्किटमधून आपल्याला काय करावं लागेल, बॅटरी काढून टाकावं लागेल आणि याच्या जागी आपल्याला याचं इंटरनल रेजिस्टन्स पुट करावं लागेल. म्हणजे आता सर्किट कसं होऊन जाणार. देअरफॉर स्टेप 3, ही स्टेप 3 याच्यामधून बॅटरी काढून टाकू, इंटरनल रेजिस्टन्स ठेवून देऊ. म्हणजे आपल्याला हे सर्किट कसं होऊन जाणार. This is R1 equal to 5 ohm, this is R2 equal to 6 ohm, and this is 1 ohm internal resistance of the battery, that is the 1 ohm. Now we have the another circuit here. Now we have to just find out the RTH by using this circuit. Now in this circuit, in above circuit, these two resistance are in series, or these two resistance are in series. Suppose consider these two resistance are in series, म्हणजे याचं इक्विव्हॅलंट रेजिस्टन्स एकच होणार आणि ते रेजिस्टन्स जर इथं टाकलं तर हे दोन एकमेकाला काय असतील, पॅरलल होते. इफ यू लुक फ्रॉम दिस ओपन टर्मिनल A and B, we can find out, we will get R2 is parallel to the equivalent resistance of R1 and this 1 ohm. Therefore, we can write the R equivalent from this circuit. R equivalent will be equal to R1 R2 upon R1 plus R2. Now here या ठिकाणी हे दोन सर्किट R2 आणि या दोघांचे इक्विव्हॅलंट सर्किट एकमेकाला कशी असतील, पॅरलल असतील. म्हणजे या ठिकाणी काय होऊन जाणार, R1 into 1, R1 R2, दॅट इज हिअर. पहिल्यांदा आपण याचं इक्विव्हॅलंट सर्किट काढून घेऊ. जर आपण याचं इक्विव्हॅलंट सर्किट जर काढलं फॉर सिम्प्लिसिटी, तर याचं इक्विव्हॅलंट सर्किट कसं होऊन जाणार, याचं इक्विव्हॅलंट सर्किट कसं होऊन जाणार, हे दोन एकमेकाला सिरीजमध्ये आहेत म्हणजे हे 5 आणि 1 6. म्हणजे या ठिकाणी आपण असं सर्किट काढू शकतो एक. This is A and B and this is C and D. Now this is R2 equal to 6 ohm and this is 5 plus 1, that is 6 ohm. Now these two resistances are in parallel to each other. Now we can calculate the R equivalent equal to 6 into 6 upon 6 plus 6, that is 6 plus 6, that is equal to 36 upon 12, that is equal to 3 ohm. That is equal to R equivalent equal to 3 ohm. And we know that R equivalent is that is RTH, Thevenise resistance, equal to 6 ohm. That is 6 ohm. Now we have calculated VTH, that is equal to 6 volt, and RTH equal to 6 ohm. Now our fourth step. What is our fourth step? Replace the entire circuit. Replace the entire circuit by single voltage VTH in series with single resistance RTH. Now we have to just draw the circuit by this is positive negative, this is VTH equal to 6 volt and this is RTH equal to 6 ohm. And these are the open terminals A and B. This is open terminal A and B. This is step 4. This is step 4. Now step 5. What is step 5? We have the step 5 is connect RL between load terminals A and B. Now connect RL. Therefore we get like this. This is A and B. This is RTH equal to 6 ohm. This is VTH equal to 6 volt, and connect RL. RL equal to, we have given that RL equal to 4 ohm, that is equal to 4 ohm. Now we have to calculate the load current flowing through this load resistance RL, that is equal to IL. RL मधून जो करंट फ्लो होतो त्याला आपण म्हणतो IL, that is load current IL. Now therefore, now here RTH and RL are in series with each other. They are in series. Therefore, its equivalent resistance will be just the addition of these two resistances. Therefore, the current flowing through this resistance will be I equal to V upon R, that is voltage here, and R is the total resistance of these two resistances. Therefore, IL can be directly calculated as voltage upon resistance, that is RTH plus RL, that is equal to 6 upon 6 plus 4, that is equal to 6 upon 6 plus 4, that is equal to 6, sorry, not it is 6, it is 3 no? Actually we have RTH equal to 3 ohm. Actually RTH equal to 3 ohm, we have taken here 6 ohm, 3 ohm, okay. We have taken 3 ohm, we have taken 3 ohm, we have taken 3 ohm, which is 6 by 7, that is equal to 0.85 ampere. This is IL. This 6.5 ampere. Now this is by using these 5 steps, we can Thevenise any circuit and we can calculate the load current, the current flowing through the load resistance RL. But there are some limitations for this Thevenise theorem. Thevenise theorem can only be applied on the linear circuits. It cannot be applied on the non-linear circuits. This theorem cannot also be used for determine the efficiency of the circuit. Thevenise theorem वरून आपण कोणत्याही सर्किटची इफिशियन्सी काढू शकत नाही Thevenise theoremचा यूज करून. This Thevenise theorem cannot be utilized to find out the efficiency of the circuit. Also, this theorem cannot be applied for calculating the power of consumed internally. Internally किती power consume होतो ते find out करण्याकरता Thevenise theorem उपयोगाचा नाही. That is, Thevenise theorem cannot be applied for calculating the power consumed internally. Now these are the 3 limitations of Thevenise theorem. Which are the limitations? What are the limitations? Thevenise theorem cannot be applied to non-linear circuit. Thevenise theorem cannot be used for determining the efficiency of the circuit. Thevenise theorem cannot be applied for calculating the power consumed internally by the circuit. Okay. Now by adopting these methods, these steps, you can Thevenise any linear circuit. Okay.